Now the today's topic is structure of atom, or you can call as atomic structure. We will discuss in this what is the structure of atom, what are the constant particles in the atom. So first of all, there is a discovery of cathode rays. This is done by Faraday. He took a discharge tube, a gas is filled in it at low pressure, and a high voltage is applied. A gas is filled in it. Now what we see is that some rays are coming out from the cathode and goes towards the anode, and he called it as a cathode rays. Now the cathode rays are nothing but the electrons, flow of electrons. Now the characteristics of the cathode rays is, now cathode rays are negatively charged particle. They are particle in nature. If we put any object in the path of the cathode rays, the shadow of the object is formed. So it shows that they are particle in nature. They are negatively charged. If we apply some electrical or magnetic field at the perpendicular to the path of the cathode rays bend towards the positively charged electrode. It shows that they are negatively charged. As I told you that they are particle in nature, so it must have some mass and the charge on it. The mass is found to be, the charge is found to be 1.67 into 10 raised to power minus 19 coulombs. This is the charge on the cathode rays, and it is 1.67 into 10 raised to power minus 19 coulombs, which is also called as the 1 unit negative charge. And its mass is found to be 9.1 into 10 raised to power minus 31 kilogram. This is the value of the mass of the electron. This is the value of the charge on the electron. They are negatively charged particle, and it is called 1 unit negative charge. If I say the sodium has got +1, means the 1 unit positive charge. If I say the chlorine carries -1, it means 1 unit charge carried by it. So 1 unit charge is equal to 1.67 into 10 raised to power minus 19 coulombs. Similarly, there is the discovery of cathode rays, and in the discovery of the cathode rays, again we take this discharge tube. Here now the gas is filled hydrogen. The cathode rays come out from the cathode, and there are hydrogen gas atoms or molecules are present. So from these atoms, some rays are coming out. That is not from anode, but they are coming out from the atoms of the hydrogen or the molecules of the hydrogen and goes towards cathode. So they are called as anode rays. One thing, that hydrogen gas is filled in it, no other gas, and the anode rays are coming out from those atoms or the molecules which are enclosed in it, and the value of the charge is found. These anode rays are positively charged, and they are also particle in nature. So they must have the mass and they must have the charge. The value of the charge is positively charged it is, and the value comes out to be the same, 1.67 into 10 raised to power minus 19 coulombs. And the mass is equal to the mass of the hydrogen atom, which is 1.63 into 10 raised to power minus 27 kilogram. हिंदी यूज करें. एनोड रेस पॉजिटिवली चार्ज पार्टिकल है, और पॉजिटिवली चार्ज पार्टिकल है, और इस पर चार्ज की वैल्यू वही है जो इलेक्ट्रॉन की पर चार्ज की वैल्यू थी. दैट इज द सेम वैल्यू, एंड द मास इज हैवियर देन दिस. दिस इज आल्सो द मास ऑफ द वन एटम ऑफ हाइड्रोजन. So these are called anode rays. If we take any other gas other than hydrogen, the value of the mass will change and the value of the charge will also change. Now I come to the discovery of neutron. The neutron, when the alpha particles are bombarded on the beryllium sheet, some rays are coming out from it, which are neither the electrons nor the protons, but they are neutral in nature, and mass is found to be the same as that of the mass of the proton. And this study was done by Chadwick. So in this, a beryllium foil is taken, alpha particles are bombarded on it, some rays are coming out from it, which are neutral in nature, means they do not carry any charge. If you apply any electrical or magnetic field at perpendicular to the path of these rays do not bend towards the positive or negative end. It means they are neutral, and the mass is found to be equal to the mass of one atom of hydrogen or one proton. So now it is clear that atom consists of three particles: electron, proton, and neutron. Now the Thompson model of atom. Thompson has given a model of atom in which he says that the electrons and protons and neutrons are present together in the atom. But Rutherford has formed an experiment. Rutherford's scattering experiment, it is known as. He took a gold foil, a very thin gold foil. Gold foil, it is very, very thin gold foil, and he bombarded the alpha particles upon it. Alpha particles are the helium particles. The helium particle, they are positive 2 charge, and 4 atomic mass unit is the mass, where 1 atomic mass unit is the weight of 1 atom of hydrogen or 1 atom of neutron or 1 particle of neutron. Now what he observed is, in this experiment, it is called Rutherford's scattering experiment. Chadwick. Right? Thompson the model of atom diya tha, with these three particles are present. But that is not a model of atom given by. Now, after the Rutherford scattering experiment, it shows that the 99.8% of the rays go straight through the gold foil, and the 0.2% of the rays get scattered. Now this shows that in an atom there is a small size thing is present, and most of the space in the atom is vacant. 99.8% is the space which is vacant in an atom, and 0.2% is the size of this thing present in the atom, which scatter the alpha rays. Some of the rays get scattered by 180 degrees. So in this experiment of Rutherford, it is clear that in the center of the atom, there is something which scatters the alpha particle. So, now on the basis of this observation, Rutherford gave its model of atom. Rutherford gave its model of atom, which says that there is a heavy positively charged, यहाँ पर एक heavy positively charged mass is present in the atom, which scattered these alpha rays. Why he called as heavy? Because alpha particles are heavy particles, which has got the mass 4 atomic mass unit. It should be heavier than this. Only then the scattering will be possible. And because the alpha particles are positively charged, so only the positively charged body can scatter them. अगर इस पर नेगेटिव चार्ज होगा तो वो स्कैटर नहीं होंगी, वो अट्रैक्ट हो जाएंगे. अगर अल्फा पार्टिकल को कोई स्कैटर कर सकता है तो वो चीज एक तो हैवी होनी चाहिए और दूसरी वो पॉजिटिवली चार्ज होनी चाहिए, और उसको नाम दिया गया है न्यूक्लियस. सो on the basis of this experiment done by the Rutherford gave its model of atom. उसने अपना एक मॉडल ऑफ एटम दिया है और उसमें उसने कहा है कि एटम के अंदर एक हैवी पॉजिटिवली चार्ज बॉडी है जिसको उसने न्यूक्लियस कहा है. देयर इज ए न्यूक्लियस which is heavy positively charged body, which is named as nucleus, and around this there is vacant space, which is 99.8% vacant space is there in the atom. So this is the Rutherford model of atom. So this is the nucleus, which consists of positively charged body. As I told you earlier, proton are the particles which are negatively charged, positively charged, and neutron are they are neutral, but both have the mass greater than the mass of electron. So it is considered by the Rutherford that nucleus consists of all the protons and all the neutrons in it, so that it become heavy and positively charged. And the electrons, which are very light, they are revolving around the nucleus in the vacant space, which are unable to scatter the alpha particles. So Rutherford model of atom is that in the center of the atom there is nucleus. In the center of the atom there is nucleus, which consists of neutron and proton, so that it becomes heavy positively charged body, and the electrons are revolving around the nucleus. So on the basis of this, we can explain some terms of the atom, which are known as atomic number, mass number. Atomic number is defined as the number of unit positive charge carried by the nucleus, or you can say equal to number of protons, because one proton carries the 1 unit positive charge. So the unit positive charge carried by the nucleus will be equal to the number of protons in it. So atomic number of an atom or element, that will be equal to the number of protons, and the number of protons must be equal to the number of electrons, so that the atom is electrically neutral. Only then the atom can be a neutral. if number of protons in it and number of electrons are equal in nature. Then the mass number. Mass is carried out only by the proton and the neutron because the electron contribution is very small. So, mass number is the sum of number of neutrons plus number of protons in the nucleus. So, this is the mass number. So, we can explain the mass number. We can explain the atomic number. Now, atomic number is represented by Z and mass number is represented by A. This is the two quantities which we can explain on the basis of the Rutherford's model of atom. Now we come to some terms which are used commonly. One is what are isotopes. Isotopes are those atoms which have the same atomic number but different atomic mass. For example, proton, protium, deuterium, and tritium. All these three have the same atomic number 1. It means the number of proton in their nucleus is 1. In the protium, there is no neutron. Here there is number of proton, number of neutron. Number of neutron, proton is 1 here, it is 0. It is 1 and 1. It is 1 and 2. Right? The number of proton, that is also known as the atomic number. So atomic number of all these three are same, but the mass number differs. So such atoms are called isotopes. I'll take another example of chlorine, 1735. Chlorine, 1737. Now, can you tell me how many protons are present in this atom? How many protons are present in this atom? These are the two atoms I have written. I am asking you, how many protons are there in this atom? Tell me. Huh? Ashish, now are you listening to me? Yes, you tell me that how many protons are there in this atom? How many protons? No, 17. As I told you, the atomic number is equal to the number of protons. And atomic number always written on the left hand side of the, and these are the mass number. Mass number I told you, that is the sum of the neutron and the proton is the mass number. Atomic number is equal to number of protons. So how many protons are there in this atom? 17. And how many protons are there in this atom? 17. How many neutrons are there in this atom? 20. Because 20 and 17 will become 37. Number of neutrons in this will be 20. And number of neutrons in this will be 18. These atoms have same atomic number but different mass number, so they are called as isotope. Understand? So number of neutrons here, it is mass number is equal to the atomic number or number of protons plus number of neutrons, and the atomic number is equal to the number of protons. Mass number is 37. Atomic number is 17. So number of neutron will be 20, or this minus this is number of neutron. Remember, if I say, take another example, uranium 92 to 35. Tell me the atomic number of this element. Huh? नहीं बोला, जवाब नहीं दे रहा. So these are isotopes. Now I come to the isobar. Isobar are those atoms which have the same mass number but different atomic number. Mass number is same. Mass number is same, but the atomic number is different. If I say the atom A with X and Y, this is B, this is Y and M. As you see, their mass number are same, but the atomic number are different. So they are called isobar. Isobar are those atoms which have the same mass number but different atomic number. Now the isoelectronic. Isoelectronic are those in which the number of electrons or the number of charge is the same. Isoelectronic are the species which have the same number of electrons. For example, chlorine -1 and argon. Its atomic number is 17, it is 18. So it consists of 17 proton and 17 electron, and because there is a -1 charge, it has gained 1 electron, so total number of electrons becomes 18. And here there are 18 electrons, so number of electrons are the same. So these are called isoelectronic. So isoelectronic species are those which have got the same number of electrons. Now I come to the electromagnetic radiations. Electromagnetic radiations. Electromagnetic radiations. The radiations which are associated with electrical and magnetic field are called electromagnetic radiation. When an electrical charged particle move under acceleration, the electrical and magnetic field are produced and transmitted. These fields are transmitted in the form of the waves. These waves are called electromagnetic radiations. They do not need any medium to travel. The oscillating electrical and magnetic field are produced by oscillating the charged particle. These fields are perpendicular to each other and both are perpendicular to the direction of the progressive wave. Suppose this is a wave. So electrical or magnetic field will be at the perpendicular to the path of the wave, and these do not need any medium to travel. The characteristics of the electromagnetic radiation is that electromagnetic radiation, which are also move in the form of the wave. So this is a wave. Now the distance between the two nearest trough or crust is known as wavelength. This is the distance between the two adjacent crusts or troughs is called wavelength and represented by lambda. Now the frequency.